we are now doing binary to octal conversion, and we say that we can do that by converting groups of 3 bits starting from the decimal point. I think we should say decimal point, and translating each group into the decimal digit. Here again, I think there's a mistake. This should be octal digit. So you are given in this case, we are given a binary number, and you want to convert it to octal. For instance, 101100. So what we want to find out is this number is equivalent to what octal number. This is clearly a binary number, so we want to convert it to octal. How do we do that? Because here the title is reading binary to octal. The method here we are seeing is that you group the binary digits starting from the decimal point, which is here to the rightmost, and you translate each group of 3 bits into an octal number. So what we do, we start from here, we count 3, those 3, and those 3. And we know that 110 from our knowledge of binary numbers is equivalent to 6, and 101 is equivalent to 5. So we could say that this number in binary is equivalent to 56 in octal. That is what this statement says. But we have another example that shows us how we can convert an octal number into binary, and we do now the vice versa of what we have done. We take 3, 5, and 1. We represent each of these octal digits using their binary equivalent, and we know we can represent 3 as 0, 1, 1, and 5 as 1, 0, 1, and 1 as 0, 0, 1. So this 351 in octal is equivalent to 1, 1. I just dropped this 0, doesn't make much value from the leftmost. Then 101, this one, and 001. And you say that that is the binary equivalent of this octal number. Just notice that you cannot take a decimal number like 351 in base 10 and you say that you group them into some groups of bits, and then you end up with the binary equivalent. You cannot do that with the decimal number, but you can do it with octal. The reason is because octal is a derivative of binary, or 8, which is the radix of our octal number system, can be represented by 2 to the power 3. That is why this 3 is the number of binary digits that we are saying can be used to represent one octal number. So we want to do another example that involves binary to octal conversion. And now in this case we have a binary number with fractionals part, and we will follow the same idea. From the decimal point, this one, we group the whole part into groups of 3. So we have the first group of 3 equivalent to 7, and the second group of 3 equivalent to, these are 2, so you can assume we had a 0 there, and this is equivalent to 2. And to the right, you group them again to, you can assume there's a 0 there, doesn't harm when you go to the right of the decimal, and 110 is equivalent to 6. So this is 0.6. Therefore, we are saying that this binary number is equivalent to 27.6. Again, not in decimal, but in octal number system.